Greetings, science fan. We are balancing chemical equations. We're on worksheet number 2 and starting back up with question number 6. So let's get right to it. If you take a look at number 6, phosphate, and phosphate is a polyatomic ion. It stays the same, so we can treat that as one whole chunk if you want. If that bothers you though and makes you uncomfortable, that's no worries. You can treat them individually as well. But let's take a look. Don't forget that we want to divide that line in the arrow and get everything the same on both sides. If you take a look, there's 3 sodiums on this side. So I'm going to do 3 times 1 sodium on this side in order to get my 3 sodiums. All right, so now that I have my 3 sodiums there, that also affected the bromines. That made 3 bromines as well. Now on this side, I only have 1 bromine, so I need to make it 3. So 3 times 1 bromine is going to help that balance out. But since that 3 is there, it's also going to make me have 3 hydrogens as well. So I'll have to keep that in mind. The nice thing is that over here, if I jump back, there's already 3 hydrogens there. So that's balanced. There's already 1 PO4 and 1 PO4 here. So that's balanced. And if you take a look, by putting that 3 in front of that bromine originally, it gave me 3 sodiums, which gives me 3 sodiums here. So it looks like everything is balanced. So in the end, I ended up with a 1, 3, 3, 1 for a balanced equation. See if you could figure that out as well and follow along. Let's coming up on question number 7 here. Let's see, we've got 3 carbons on the product side, only 1 carbon on the reactant side. So I'm going to put a 3 there to give me 3 carbons. I also have 8 hydrogens on the product side and only 2 on the reactant side. So 4 times 2 will give me 8. I think I'm nice and balanced that way because I have 3 carbons on both sides, and now 4 times 2 hydrogens gives me those 8 hydrogens, which cancels out with the 8 hydrogens I already had. So that one's balanced. That looks like that ended up being a 3, 4, 1 to balance it out. Taking a look at number 8, I'm going to divide my products and reactants. Remember, reactants are on the left, products are on the right. Let's take a look at this. Manganese, there's only 1 and 1, so that's balanced. Okay. I have 4 iodine and 2 iodine, so I need to make them both 4. So I'm going to multiply that by 2. By doing that, I'm going to get 4 iodine, but that also now gives me 2 calcium, so I'll have to make sure that can balance. But I know I have 4 iodine over here, so at least my iodines are balanced now. I also have 1 manganese on both sides. So those are balanced so far. That looks good. Now, since I got 2 calciums on this side, I'm going to put a 2 here because 2 times 1 calcium will give me 2 calcium. Also, 2 times 1 oxygen will give me 2 oxygen, which is great because over here I have 2 oxygen. So to me, it looks like everything's balanced out. 2 calcium, 2 calcium, 2 oxygen, 2 oxygen, 1 manganese, 1 manganese, 4 iodine, 4 iodine. So this becomes a 2, 1, 1, 2 in order to balance it. Pretty nice work, guys. Good job. Number 9, we're going to divide the reactants and product side. So let's do this. All right. Well, first of all, this parentheses has a 3. So that means I have 3 hydrogens and 3 oxygens. That 3 distributes to everything in the parentheses. So let's just keep that in mind. If I take a look, I have 3 hydrogens on this side. I have 2 hydrogens on this side. Unfortunately, they're not equal, but the nearest number that they can be equal to is 6. So I'm going to try to make both hydrogens 6 so they can balance out. Now to do that, I'm going to need to double this compound because 2 times 3 hydrogen will make 6. So remember, this 2 distributes to everything in that compound. So 2 times 1 iron is 2 iron. 2 times the 3 oxygen give me 6 oxygen now. 2 times the 3 hydrogen now give me 6 hydrogen. All right. So now I have 6 oxygen, 6 hydrogen, and 2 iron on the product side. The only reason I did that, remember, was to balance out the hydrogens. I'm going to put a 3 here because 3 times 2 will give me 6 hydrogens. So all that work was really just to make sure that my hydrogens could balance out. But now that I put that 3 there, I also have 3 oxygen right here. Now you might be thinking, oh no, I have 3 oxygen on the reactant side and 6 on the product. They're not balanced. What do I do? Well, don't forget, there's also 3 oxygen right here. And 3 oxygen plus 3 oxygen gives you 6 oxygen, which cancels out with that. So right now my oxygens are equal and so are my hydrogens, so I'm sitting well. The last thing is my 2 irons, but I already have 2 irons there on the reactant side. So actually this worked itself out and I'm nice and balanced. So I'm gonna leave that as 1, 3, 2. All right, nice job. Coming in at number 10, divide my reactants and product side. Here we go. Well, it looks like I've got 2 carbon and 2 carbon. That's good. It looks like I have 2 plus 2 hydrogen, so I have 4 hydrogen. Yikes, and I have 6 over here. So since my carbon is already balanced, I don't want to really mess with these guys over here. So if I just take 2 times 2 hydrogen, that's going to give me 4 hydrogen, plus the 2 hydrogen over here will really give me 2 plus 4 hydrogen will give me the 6 hydrogen to balance out. So in the end, this became pretty quick and straightforward. I ended up just doing a 1, 2, 1 to balance it out in order to get those hydrogens equal on both sides, because the carbons are already equal on both sides. Coming to number 11, I've got reactants and products broken up. Here we go. VF5 reacts with HI to yield V2I10 plus HF. Wow, so we got a lot going on here. Let's see what we do here. Well, I'll start with something simple. Vanadium, there's 1 and 2 on both sides, so let's equal that out. So if I put the 2 there, I now have 2 vanadium, but 2 times 5 fluorine gives me 10 fluorine. Okay, that's quite a bit. But now at least my 2 vanadiums are canceled out. Now if I have 10 fluorine, I'm going to put 10 here to make 10 fluorine. 10 times 1 fluorine is 10. But now that also goes to the hydrogen. So now I have 10 hydrogens. Wow. Okay. 10 hydrogens over here means I need 10 times 1 hydrogen to give me 10 hydrogens. But that 10 also goes to the iodine and gives me 10 iodine. Luckily, I already have 10 iodine over here, and I think everything ends up canceling out. 2 vanadiums, 10 fluorines, 10 hydrogens, and 10 iodides. Nice. So it ends up being 2, 10, 1, 10. Remember, you can leave those 1s as blank if you don't want to write the 1s in there, but some of you like to kind of finish it all up in one, wrap it up in a little bow. But there we go, that's balanced. All right, if we look at number 12, let's break this thing down into reactants and products. 1 osmium, 1 osmium, 4 oxygen, 2 oxygen. Okay, well, let's try to balance out the oxygens. If I put a 2 there, 2 times 2 will give me 4 oxygens to match this 4 oxygen. But now, 2 times PT gives me 2 platinums. So I only have 1 platinum over here, so I'm going to try to get 2 platinums by multiplying it by 2. So now my platinums are evened out, but 2 times 4 chlorine gives me 8 chlorine. All right, let's jump over to here. Ooh, I already have 8 chlorine. Excellent. So those are balanced out. Let's see, what haven't I taken into account? I think osmiums are already 1 each. So let me just triple check to make sure everything naturally balanced out. 1 osmium, 1 osmium. 4 oxygen, 4 oxygen. 2 platinum, 2 platinum. 8 chlorine, 8 chlorine. Nice. This ends up being 1, 2, 2, 1 to balance that out. Nice work. Coming in hot with number 13 here, I broke it down into reactants and product side. Got 1 carbon, 1 carbon. Let's see, 4 fluorine and 2 fluorine. Okay, so if I have 4 fluorine over here, I want to get 2 times 2 to give me that 4 fluorine right there. Okay, I've got 1 carbon and 1 carbon, so I'm good there. 4 bromine though. Ooh, so I have 2 over here. So 2 times 2 bromine will give me the 4 bromine. All right, let me double check to make sure I balanced it. 1 carbon, 1 carbon, 4 fluorine, 4 fluorine, 4 bromine, 4 bromine. Nice. 1, 2, 1, 2. Sounds like boxing. Nice work. Looking at 14, I'm going to divide it by reactants and product side. Let's see what I have here. I have 2 mercury and 2 mercury, so they're happy. 2 iodine, so they're happy. But 2 oxygen and 1 oxygen. Uh-oh. Okay. So if I have 1 oxygen, I have 2 over here and 1 over here. I'm going to need to multiply that by 2. That 2 distributes to not only the oxygen, but the mercury. 2 times 2 mercury is 4. So now I have 4 mercury. I'm going to have to jump over here and make it 4. So 2 times 2 mercury is going to give me 4 mercury. But now that 2 times 2 gives me 4 iodine as well. If I have those 4 iodine, then I got to jump over here. I have 2. So 2 times 2 iodine will give me 4. All right. Let's see if I balance this out. 4 mercury, 4 mercury, 4 iodine, 2 oxygen, 2 oxygen. Nice. 2, 1, 2, 2. Ends up balancing it out. Good work. Let's take a look at the last one, number 15 here. I have 1Y, yttrium. Sorry, split that in half. Ooh, I've got 2 whole nitrates because that 2 for the whole thing. Look at that. 2 whole nitrates. 1 gallium, 1 whole phosphate, PO4, and 1 whole phosphate, PO4. Hey, take a look at that. That one actually is already balanced. So you could leave it blank or throw 1s in there if you'd like to balance it out. But that worked out nice. But great job, Chem Fam and Science Fam. We did it. We balanced and we're all set. Take care.